Good morning. There's a new term in AI that you need to grasp. It's context engineering. And context engineering is an emerging distinction in how to work with AI that goes beyond prompt engineering. And so, if you were planning to be a prompt engineer, you can put that aside. And this context engineering term was voiced by Andrej Karpathy, a major thought leader and advanced AI researcher. Context engineering is a new way to think about how you work with AI that can reason, remember, use tools, and do planning and execution autonomously. We call them agents. Prompt engineering was where we tried to predict and specify everything we needed up front in a response from an AI, and we could define the sequence of the steps that the AI would take and the expected outputs, and we could provide pasted context data or as a file upload. But context engineering, the user provides a simple objective and a context framework, selecting tools and documents, and the agent does the planning, discovery, and adapts based on what it finds using the tools and data, and designs the final output, drawing from its entire research journey. So get used to smarter and more capable AI assistants. Call them agents because they can chat with you, use tools, remember, and learn to do all this on their own. Today is July 3rd. This is the Daily AI Show, and I'm here with Beth Lyons and Junmi Hatcher. And I'm going to step now into a bit of an instruction on this. So, take notes. There'll be a quiz later. User instructions in this world of context engineering are going to become simpler, not more complex. So that's the good news. Prompt engineering as an approach has become more complex on the AI side, but on the user side, it's getting much easier. When we were doing prompt engineering back in the day, we would create massive, complex instructions trying to cover everything from context to role to be played by the AI to the constraints and the formats of output. Put that all into a massive prompt thing, put it in your prompt library, and try to reuse that. Well, now in the world of context engineering, we can state a simple, clear objective. And I'm going to give you an example here. We're going to take a SaaS company that needs to understand their competitive landscape and identify expansion opportunities in the European market. And first, here I'll give you an example of what a prompt would have been in the pre-agentic days back in 2023 and 2024, so many years ago in AI world. So it would be a single prompt, a single inference run for each time you run that prompt. So here's the prompt. Analyze the European SaaS market for project management tools. Include competitor analysis, market size, growth trends, key players, pricing strategies, and recommend 3 expansion opportunities for our company. Our product is a mid-market project management tool with strong Gantt chart capabilities, currently priced at $15 per user per month. We have 50,000 users in North America. Provide a comprehensive report with specific recommendations and supporting data. Okay, that's a well-written prompt. It's not a structured prompt where you provide different sections in Markdown, and there are more and more complex ways to express a prompt and to include variables that would allow you to reuse that prompt against different analyses if there's a certain structure that you want your AI to respond with. But there were problems with that old approach. A single prompt often tries to accomplish too much, and there are vagaries that work their way into that. Like, for example, the order in which you express ideas in your prompt can have a big impact on the way the inference is actually generated and what the response output is. And importantly, it's a static analysis. The AI goes in and depends on its own resources and any context data you supplied by pasting it in along with your prompt or adding a document, for example, as a file upload that gets compiled into the prompt. And so Importantly, in those days, we didn't have access to web search either. So it was based only on the AI's knowledge. And so there wasn't access to current market data, to competitor websites, or real-time pricing for this particular prompt. So what you'd typically get out of such a thing would be a fairly generic report with outdated information, broad generalizations, and then you could accomplish a kind of multi-turn improvement of that by continuing to interact with the AI and asking it to refine its output. But that put a lot of load on the user to guide the AI through its successive turns. So now, context engineering using a memory-driven agent is much simpler for the user. So here's what we do. We provide a simple objective. I need to research European expansion opportunities for our project management tool. Focus on identifying the 3 most promising markets and specific entry strategies. And then the context engineering part is we provide a guide to the model, to the agent, for the context. One of them is to provide tool access. So we enable web search. We can specify specific, yes, that's right, specify specific. That's not redundant. Competitor analysis tools. We can, reference certain market databases that we wanted to use, and just provide known resources as a list of things that it should consider. But it's going to go out and figure out what else is available out there as well, using its capabilities. And we also might specify certain memory steps that we want, like specify what data and insights should be retained across research steps. And we could provide success criteria. And we can also upload some documents that we have, like our company profile document we could upload. Well, that's not terribly different from the prompt engineering approach. But here's where the magic happens. Now, having been given this context structure, the agent starts its execution process. The first thing it'll do is ask you questions for things that it thinks require clarification before it can execute on your objective. And you can answer those. And then let's say its first step is to do a market landscape discovery and add that to its memory because you've asked it to create a picture of the competitor landscape out there. Step 2, it'll take each one of those competitors and do a competitor intelligence research step and commit that to its memory. Third, it'll do a deep dive analysis with the context that it has thus far and redirect its own research based on gap analysis. And you've seen this possibly if you've been using agents recently. It'll say, oh, it's showing its thinking and steps in the process. And sometimes that's suppressed. You need to kind of click that open and watch as it does that to have an appreciation for just how clear and adaptable the agent's capabilities are. But it might say, well, I don't really know enough about this company, and it seems to have a large market share. So I'm going to go back and dig deeper on that and try to find some other resources. And then its next step would be opportunity listing for this company that I'm doing the evaluation for. I'm going to evaluate each of the opportunities and then validate them using the accumulated insights and research that I've done. And finally, I'm going to present this as strategic advice, drawing from the entire research journey and deep pre-trained knowledge that I already possess about these things. So, all of that was done by the agent. And that removed the necessity for me specifying the step-by-step process I wanted it to follow in order to accomplish a really thorough strategic analysis of the European market. What's the fundamental shift in this? It's the shift from stateless action by the AI. It's going to take a compiled prompt and it's going to do an inference run, and it doesn't retain the state or translate that into the next one except within its narrow context window, to a stateful process from a single turn of inference where each response is in effect in isolation from the prior ones, to multi-turn reasoning agents accumulating knowledge through real-time investigation, and using memory as a bridge between whatever context you provided and the agent's autonomous actions, which added to the context progressively, accumulating knowledge to shape future decisions as it goes through this process. So there you go. There'll be a quiz on that later. That's the introduction. I now turn it over to my colleagues for questions and additional advice.
Go, Jimmy.
Right. Thank you, Andy. That was a great real world example, and I'll probably be applying that to some of my own projects. It's clearly laid out there. I did want to highlight one of the sections about context engineering, and that is when you said, in addition to whatever context that we provide. And I think that's also an important part, is the context that we provide. I think context engineering is a term, just like how we have to come up with some label to codify the various things that we're talking about. So I think under context engineering is a lot of techniques that have existed and things that we talk about individually, but are now under this concept. So for example, when we talk about RAG, right, we talk about bringing in our own information, our own database. So for a company, there's always going to be tons of documents and internal documents or product documents and all these kinds of things. And that is going to be a database of information that we're going to want our agent, our AI, to access. So that system, the RAG system, is part of the context engineering, the overall context engineering concept. It's those resources being available to the agent. And I think the other part of that is, and there's many different ways that information gets in there, whether that be conversations, past conversations. Like if you're having a customer service bot, you want to know what the past conversations are with that customer regarding your service or product. You want to know what context we're talking about X, Y, or Z, right? And all of that goes into the overall assessment by the agent of knowing what information at the right time to retrieve, right? Because our limitations, or the AI's limitations right now, is how much of the window do they have, how much of the active memory that they're using and that they can pull in. And right now that's a holy grail thing. If we can figure out long-term memory, that would be great for AI. But we need to be, so right now for context engineering, part of, beyond just the agentic aspects, is the information that we provided and what information at what time, so that can minimize any hits to performance and increase accuracy and things like that.
Right. And so there's actually a discussion happening in the chat as well as is this just like being a really good instruction giver? But I think what Jumi started to surface in this discussion is that it's not just what you're giving, but actually what you're taking away, or what you're shining the light on also. Because if you have a giant context window and you just shove all of the context at it, you haven't prioritized the context, right? And that is one of the challenges that this starts to address, because you can overfill context with not pruning it, right? There's a quote, and I'm unsure whether this is a quote from, yes, what is his name? David Kimai, or whether it's a Karpathy quote, because the sentence that I got it in is inconclusive, but it describes context engineering as the delicate art and science of filling the context window with just the right information for the next step, right? So we are We are right sizing the right information at the right time. And what's implied in that sentence is then we're removing what is no longer relevant after that step has been completed, or we're condensing, right? So it is a little bit more involved in this context.
Yeah,
Yeah.
I want to tie what Junmi was saying to what you just said, Beth, because the original chatbot RAG systems were generally used to confine the responses of the chatbot to the data that was relevant. So just only use these resources that we put into this knowledge base when you form your responses. And the mechanism of a retrieval augmented generation RAG system is you take the user prompt, you embed that, and you do semantic similarity vector search in the database to find only those things within the database that are relevant to the user query. But now, how does that work? That simple model of RAG, how does that work as memory, if you will, or context reservoir for an agent that's going through multiple self prompts and multiple additional inference prompts? And is each one of those going to a RAG system and pulling out things? And how do you delete stuff from the current context memory in order to provide prioritization for the other one? And we don't have the answers to that, but fortunately, that's what the research engineers at all of these major companies who are developing very, very clever autonomous agents are working on. And they are improving those capabilities all the time. But yes, we're talking about how do we provide the right context without overflowing the context window of any individual inference? And then how do you take the results of that one inference run and save the important parts of it, and then keep that as a contribution to another inference run that is going to generate another output? And who's orchestrating that whole thing? Well, the agent is orchestrating all those things, but that's some magic behind this curtain that we don't really see or understand. Is they're figuring out in those labs, they're figuring out how to do this multi-turn memory plus inference retention context accumulation that becomes the basis of the next reasoning step in an inference run that is being done in parallel, I presume, that says, okay, here's the objective again. What did we just learn from this stuff? And what's the next step? What's the next logical step that I can take? And I don't depend on the user to provide that. I figure it out myself as the agent.
Mm-hmm.
Yeah, I think you really touched upon talking about the, I guess, the context engineering framework, if you will, in those different layers. And specifically, one of the ones that we've been really identifying here so far is the orchestration layer. But if we do a quick breakdown, the kind of concepts that, if you want to approach context engineering from a technical side of things, you could break it down into a framework. So, for example, there's many different layers, right? Like if you have any familiarity with Ethernet or packets or anything like that, each how that information's transferred, they talk about it in various layers. So, for example, in context engineering, you'll want to understand there's the model layer, right? Everybody understands the model layer. This is where the model is going to live. This is where you're interacting, and this is where you're giving some initial prompts and guidance and things like that. Then, like Andy had already pointed out, there is the orchestrator or the orchestration layer. And that seems to be where a lot of the heavy lifting is being done, right? This is where your model or models are being orchestrated to either retrieve information, process information, getting the pieces that they need, or getting work done. Then there's the tools layer, and this is what empowers our agents, right? Giving the agentic features is this tools layer. This is to know where to get the information and when to get the information. And I think that's that crux of what you're talking about, Andy, is this tools layer is being able to grab the relevant information, like you pointed out, Beth. Grab that relevant information, or just in time or real time, pull it in for its relevance for whatever the particular task is that the orchestration layer has identified, and then being able to process
Yeah,
that.
let me add a point to that, which is, there are user prompts and there are system prompts behind the scenes that are guiding the thing, and those things get combined when an inference run is done. Well, similarly, in this case, there's an orchestration process that's happening behind the scenes that we don't understand. We don't see, it's not presented to us, but you see the results of it in the thinking process that is revealed in the UI of many agents. And that part of that is a tool use. Normally, when we talk about tools, we think about, oh, web search, this database, go out and get that thing, those kinds of tools, or a feature server out there on the web that can generate an image. Those are tools that can be called on. But that's external access tools. There is, I think, a need to understand that there are internal tools that the reasoning agent is accessing and exploiting in order to produce this incredible orchestrated symphony of actions that result in the really amazing results that the new agents can produce.
And so let's talk about stateful memory for a second here, because there are 3 different layers of that. One is that you set what is known in coding as a variable. So, right, when I say go, you say yes, right? Like, so when I say go, whatever go equals is defined as the state of that variable, and that variable can get updated within this context run. So the new information gets overwritten. That's only true while you're running this iteration, right? When I say go, it may mean something else in another run, right? Because let's say go is the information about my competitor's company, right? That's going to shift each time I run this thing. There's also memory that gets written about the content, the like topic or the function that this run is doing, right? So that's the next level, and that is likely written into something that gets called every time this function gets called. So we have the individual state as the variable, then we have the function, and then we have the information that is always true about me, who is running it, right? Or the company, or those kinds of things. And that's the maximum of that. And each of those gets pulled at an appropriate time. And if you're willing to go with me on a little journey between magic and improv, I was like, something came across my For You page, which are those, I often see them as female magicians who change like outfit right in front of you. So the first outfit they're in is longer, it has a lot of stuff. They do something over here and boom, they're in a short skirt and it's all pink, right? And boom, there's this. All of those things are set on the stage, right? So all of that is set up before this act can occur. That's very pre-planned context, prompting, all that kind of stuff. If you contrast it over here in improv, right, I'm setting it all at the same time, and I'm doing it in an imaginary way, right? Oh, thank you so much for the tea, right? Smells like lavender. I have now defined that this, which totally doesn't exist until I just held it in front of you all, is a cup of tea that smells like lavender, right? That's the other end of this. We're making this up as we happen, but because we've agreed on what we're calling it and we're engaging it as if it's real, these are 2 ends of that spectrum in context, in a very Beth way.
Well, I think they're great analogies because, you know, any analogy is really great when it can bring that technical to your lived experience, right? This is how I like to learn: is give me examples. Always want more examples. So so clearly being able to define what that process is, I think is will be helpful to people. Now, I also tend to like to have things written out. So I I have like a 6-step or 7-step 6-step thing that got broken out for me in terms of if you wanted a practical guide um, to to understanding context engineering, or how to build with context engineering in mind. So first, you want to understand your use case, and we kind of explored this in the vibe coding live sessions that we've been having. Is there's a lot of pre-production that goes into the process. You really kind of want to understand what your MVP is, right? And that's the very first step. And so before you even, like, if you're going to build an application, you want your PRD, you want to understand what you're going to be doing. So uh, diving head first, but understanding what pool you're diving into, right? um, then in this context, you want to identify all of your data sources, right? That's kind of what I was trying to point out earlier. Is you want your reg sources, you want your conversations, you want your all of the data points that your use case, right, is going to touch upon. Anything that you might think is going to be relevant to that. So, for example, if you want to integrate an AI into your Slack channel, and that's your primary form of communications, and you want to create an AI agent that's going to help your internal, your internal teams, you want to be able to use those conversations as sources of data to improve what that interaction is going to be. Next is you're going to want that orchestration framework, or that orchestration layer. You really need to identify what you're going to be using for that. So one that's been around a long time in mainstream AI terms is LangChain. LangChain's a great orchestration framework. In fact, LangChain is what the AI agent um, module or node from N8N is the back end of how that is built, is using LangChain. Then you kind of this is where your research comes in, and this is like keeping it relevant, right? So you want to filter out, like you said, Beth, taking out things that are unimportant. And then you're going to want to optimize for performance. Now, this is the tricky one, right? So this I think is where the nitty gritty, tedious part's going to come out of, is making run after run, testing your system or your agent for optimization, performance optimization. And this is cutting a little way here, maybe moving the process around. Maybe if I wait 2 seconds here, I won't have to wait 30 seconds here. And so I think that's where the nitty gritty engineering really comes into it. And this is the tedious part that nobody really likes about about engineering, is just making each of the parts work as best as possible. And I think this, and then this next one, I think, has been really relevant recently because of the rise of like MCP, right? Is privacy. Privacy and data protections is kind of the gap that what immediately any IT department is going to look at implementing. It's like, oh yeah, these are great. Now, is it going to open up a big hole in our security protocol? Are we going to be dinged by compliance issues? And this is these are the things that are going to slow down implementation for sure. But if you go in understanding what these requirements are, is your data at rest. What is happening to your data, as it's transferring? Where are you storing it? What, all of these things that are important to any size company. And I think we lose a lot of that in the conversation of or the hype around, hey, anybody can vibe code now. Anybody can make an application. Anybody can create XYZ agent, AI agent system. Let's just plug everything in there and go. And while I am a proponent of go fast, break it and then fix it along the way kind of concept. I think if people learn some basic approaches, just simple best practices, or at least be aware of them when they have their conversation with their vibe coding agent, or they have or they're developing they're knee deep in development of their automation or their AI agent focused context engineering, prompt engineering, all those kinds of things. If they are just cognizant of these general broad stroke best practices and include them in the conversation, just like we have learned over the last couple of years, what context you provide in your prompt helps the AI understand that that's important to you, and will come up with suggestions or come up with solutions. So this falls within the realm of knowing how to speak clearly and communicate clearly, and have a really well created idea and conversation that you're having. So I guess this goes back to those initial conversations. It's like, oh, let's just talk to the AI. These are the kinds of things that I want to do. What should be important? And so I think paying attention to that as well in anything that you're doing is going to help you down the road.
Absolutely. And I feel like what we're seeing in this shift is a need for a couple other pieces to come into this, because I appreciate what you're saying, Jumi, like what will be important for this. But then the very next piece after it's run needs to be the evaluation. And agentic systems often have that built in, right? So you see, if you unwrap it, you can see it saying, oh, so I did this, but that didn't work. So now I did this worked. Now it's going to go back and and remove the section that said this was a possibility, this over here, right? I took a left turn. Nope. Dead end. Took a right turn. Yes. Okay. So there's more stuff in that direction. And as I know Andy has experienced, if your agentic system doesn't do that, when it hits like the dead end further down on the right turn, it comes back and it has to remember the left turn was wrong again, right? Like that's part of that process of updating your state based on the knowledge that you're experiencing as you're going through this. And I think what I would really love to see is a more visual representation of what's happening. You remember the old encyclopedias where you could like, they had cellophane pages and you could like put the muscles on the skeleton and then you could put the organs on the muscles, probably in the wrong order, sorry. But those kinds of things, it would be really nice to have a schematic that you could then turn on the memory layer, right? And each, like the stateful memory versus the run memory versus the skill memory, right? This is a research agent versus this is a content production agent. That memory, and then the memory of like the overall context that this is happening in my business, my personal life, whatever that is. That would be interesting to be able to overrun that, or for your governance people be able to like, hey, let's just turn that on. What are our governance, what's happening with access to the data, so that then when you turn that on, there would be like 7 bright yellow sections and 2 bright red ones, and they would say, hang on, right? Let's just see what's happening in that, because there is evaluation that needs to be done throughout this process to make sure you know what's working and it's being updated in what's working, and then what the effects are. And there are lots of schematics, right? N8N, Make, they all do their schematics. You can also do schematics like in Mermaid, like you can do a little process map, but there isn't this idea of being able to visualize different levels of this for different needs, right? For different things that are important.
Yeah, I think you touched upon. I'm like, my brain is thinking of, from the example that you're giving, I'm thinking a fantastic tool or service that you could add into your process would be a cross-sectioning analysis and monitoring tool, right? You're talking about what we want is monitoring, what we want is logging, what we need is feedback loops, whether that just be from the customer, whoever your shareholders are in this process, who's going to be touching the AI in whatever capacity we need a response from that, and identifying, having a clear system to put those in. Like, I would love to have just a module or layer, like you're saying, that it's like, okay, cool, this part of the process is run. How is this relevant? Here are the check boxes that I want to see. And so having a cross section kind of thing like that would be a great service that you could apply across the board, or you could build it. All right, Beth, $1 million idea. There you go. Build it. But I think overall, what this brings up is the question of that. What are the potential pitfalls? And Andy, Beth, I'd love to get your insights on what do you think the potential pitfalls that people need to understand when they go through the context engineering process.
Well, I have an example. I was fashioning with Claude in this particular case. I was fashioning the sort of the outline of what I was going to present today at the top of the show, and its original result, was satisfactory, but didn't really hit on one of the key elements, which is the importance of memory, and how memory is really a bridge between, inference and agentic action. Like, you have to accumulate things and then use those. And so I asked it to kind of revisit the outline, and which is being presented over there on the canvas. I revisit the outline and try to, include the importance of memory. Well, it redid the entire thing, like that memory is the be all and end all of everything in the universe, and it was totally overblown like that. So that's where you have to be aware of the human in the loop is really critical here, because if I just took as, legit the revised outline, then and I allowed this sort of overweight of the idea of memory as a fundamental component of every step in this sort of context engineering process. It even got to the point where it was suggesting that AI engineers have to do memory architecture. This is like, yeah, okay, that's an important point. It's a side point, in effect. So, the AI is very good, but it doesn't really have the grasp of priority and level of importance. And if you feed it that as a point of information, it might overweight your input. That's the example. And so that's one of the ways that this thing can go awry.
And I think that's a really great point, Andy. And I think it is, like we need to be thinking in multiple dimensions now, I think, because we've talked about gravity words, right? So if you say metaphor or give me a story, any of those kinds of things. Let's add some comedy into this. In your prompt, you have erased all of the other words that you said. You're just gonna get once upon a time, and it's like when chickens chew bubble gum, right? You're gonna get way bat crazy, those kinds of things. I think we have the same thing happening in terms of action and the weight of action, or memory and how much memory overwrites. And I'm like thinking of a big group number of pirates and Penzance, right? And you're saying, hey, can we get a little more light on Buttercup, right? What I just mean, like, just turn that up like 3. I don't mean darken the entire stage and now it's a spotlight on Buttercup. And I also don't really mean even to elevate Buttercup above the people who are singing over here, right? Like, there are those kinds of things that are understood when you understand the role in which you're being asked that. And I don't think we're there yet with AI, and it's hidden in this agentic layer, right? Because it's not, the agent is not like responding and going, excellent. So just to clarify, you mean memory is the most important thing ever, and that everyone should consider memory before we take any steps or generate any tokens. It's not going to do that. It's just going to give you the results of it. And you're going to be like, what? Why? Why? We were so close. And for that, if you then say, go back to what you were doing before, split the difference. I have done this for shows recently. All of that is within your context window. Sometimes that's helpful. Sometimes it's not. You just go back to the previous step, erase that generation from its history, that action and generation, and then do it correctly. Because if you do it correctly, then that's the history that it's looking at. And that is one of these pieces of summarization and pruning, right? So that's another piece that this context engineering takes into consideration. That you can also go through, great, this was the end result. What can we prune in the memory of how this happened, or the state definition of how this happened? So
yeah, I want to weave that back to your comment earlier about evaluation. And there's an internal evaluation process that's clearly taking place that I referred to as a gap analysis in its plan that sees, okay, well, I didn't really get a satisfactory set of data around this point, so I've got to reinitiate a new plan that's going to go out and search that out. That's an evaluation step, saying no, that the original plan didn't execute fully, and I'm not satisfied with what I've got. And then we've been talking about this external validation / evaluation that we make when we see that some response or change that the AI has taken as a result of our providing additional context. That goes awry and ends up squandering a lot of good, well-organized work before, and changing the whole nature of something. That the response to that human evaluation and the internal evaluations that are happening by the agent are short at present of the ideal, which is a really smart agent that can maintain sort of hierarchy of the importance of concepts in its ultimate strategic result. Like, it's not strategic if it's, upside down in terms of priority and hierarchical organization. And I'm not confident yet of AIs that they can maintain that, especially through multi-turn interactions with a human guide, where we're doing iterative, redirection of the model in order to refine the output.
Mm-hmm. And this is one of those pieces, I think, also where the agnostic agent framework versus the within a particular flavor of frontier lab framework is likely to be part of what moves forward and is a little challenging if you're pulling it from Claude or you're pulling it from OpenAI or you're pulling it from Gemini. As we've all noted before, sometimes when you're stuck, you just give it to the next one, right? Like, ooh, Claude, Gemini did a look. It's like doing really bad now. I'm sure you can get it. There is context within that makes that like the probability of that for Claude is that it's going to find the thing. The probability for Gemini is that the thing existed already and it just needs to go back in its haystack and look at what it was doing before.
There's a very similar issue that happens with coding agents. So I use Lovable and Replit, and both of them have a tendency as agents to, when I point out some defect or, and I need it to correct that, quite often its initial response will be to, oh, I have to rewrite this whole thing. Right? I've got to go do this. And that leads to serious problems where it's going to make changes to different parts of the application that are maybe sensible if you're going to do a complete refactoring of something. But in fact, it was an issue that was correctable with a much smaller initiative.
Right.
Right. And so it overwhelms the problem with a really comprehensive solution that actually introduces a lot of additional problems. Now, I have found recently, and as I've shared with my colleagues here on the show, I found recently that by, first of all, not allowing the agent to just go ahead with, proposed changes, I evaluate those changes. And the way I do that is I give it to another AI coding agent, not Lovable, not Replit. I give it to, in my practice, I give it to Gemini 2.5 Pro. And Gemini 2.5 Pro very often will say, oh, Lovable's suggestion here is way overkill. Now, here, tell it to just confine its correction to this, and then you give that instruction back to the chat agent, this sort of planner agent within Lovable, and it says, "Oh, you're absolutely right. My original plan was way overblown." And this is the kind of thing that is important to understand when you're marshaling the resources of these agents. They're very capable, but do have tendencies to overreact, let's say.
Yeah, no, it's puppy training, right? It's like, I'm so excited. I will do all of the things for you right now. Like, no, I asked you to sit calmly.
All right. Well, we're at the end of our allotted time today. So do you guys, either of you, have anything else to add before we shut down?
Well, I'd like to just to bookend or cap this for people who are watching later, right, who might not understand, or what is the basic thing you need to understand about context engineering, right? So here's a perplexity answer to a conversation that I had. And essentially, it defines context engineering as practical or the practice of providing AI systems with the most relevant information at the right time to improve their accuracy and usefulness. You want to balance relevance, privacy, and performance to avoid overwhelming or slowing down the system. And also to remember that it's ever evolving. So it requires continuous refinement, user feedback, and ethical considerations to keep AI interactions helpful and trustworthy.
Very nice. I'm going to add a point, which is context windows. Those are variable depending on which, reasoning LLM you're working with, ranging from something on the order of 300,000 for Claude to a million to 2 million for Gemini. And that makes a big difference in the level of retained comprehension that the agent can maintain through a session. But there's a limit even there. And I frequently have to stop a chat with that agent because it's getting it's getting it's so slow because there's this enormous chat it's having to consider every single time it responds. And so there's a latency problem that is introduced when you start to approach the million token context limit. So you have to stop that session and start a new one. So that's just another point to keep in mind when you're talking about context engineering. Understand what the context limitations are of the agent that you're working with. Okay, that's a wrap. I want to invite everybody to join our community at thedailyaishowcommunity.com. And there you can join our Slack community. It's free. And you can meet some of the other people who are routine watchers of the show and what they talk about in respect of AI. And also at thedailyaishow.com, you should sign up for the newsletter, which is a really compact digest of information that you'll find useful. Comes out once a week, and we put a lot of time and effort into it to make sure that it's something that is worth reading. So check that out. Subscribe to that, please. And come visit us tomorrow for our show number 500. We've done 500 of these shows. Every one of them, possibly with a few exceptions, has been chock full of useful information about AI. So thanks for listening today. Join us again tomorrow and sign up for the newsletter. It comes out Sunday morning. Thanks all.
Aloha.